Morning, it's Coach Day. Today we're going to go over writing exponentials from word problems, but today they could be growths, decays, or they could be regular. And some of our problems are going to have tables, so you'll have to use what we learned yesterday as well. Now, number one says a certain type of cell triples in number every hour. Initially, there are 16 cells. Write a function that models the number of cells produced in every hour. Well, we know our base equation is y equals a times b to the x. And we know that in our base equation, this is our initial, and then this is our either growth or decay, right? Now, we know that it's tripling so it's going to be a growth, and there's initially 16 cells. So we just go y equals 16 times 3 raised to the x. If it's tripling every time, it's going to be multiplying by 3 every single time. That's it. Now, we've got number 2. Readers R Us bookstore sold 385 books in the month of May. The owner expects sales to increase at a rate of 3.5% each month. Well, this is giving us a rate this time, and it's an increase, so that's a growth. So here's our base, y equals a times 1 plus r, and raise that to the x. Now, our rate, it always has to be a decimal. This is a percent. So remember, change your percent, 3.5%, into a decimal by taking your decimal place and moving it 1-2 spaces to the left. So our equation then, y equals, our initial value was 385 times 1 plus, and there's our decimal, 0.035, and raise that to the x. Now, if we want to simplify that, we can combine inside the parentheses and get 385 times 1 plus 0.035 is just 1.035 raised to the x. All right, number 3, an ant colony of 2,000 ants is treated with pesticide. So they started out with 2,000. That is your initial. That should be your A. The colony decreases at a rate of 40% per hour. So 40%, change it to a decimal, 1, 2, so it'd be 0.40 or just 0.4. Write a function to determine the size of the colony. So we get y equals a times 1 minus r to the x. That is because this is a decrease. It's a decay. So now let's plug in what we know. Y equals 2,000 times 1 minus 0.4 to the x. Now we can simplify this. So y equals 2,000 times, and 1 minus 0.4 is going to be 0.6. That is basically what we're doing. We're reading, we're writing the problems. All right. So number 4. Jordan deposited $150 in a savings account. The account earns an annual rate of 5.5%. So we got our rate. Change that into a decimal. 1, 2. So got to add a 0 there, 0.055. Write a function to determine the balance in the account. Well, it's a growth, so we're going to have y equals a times 1 plus r raised to the x. A, our initial, they start out with 150 in the account. 1 plus our rate of 0.055, and raise that to the x. We can simplify this to y equals 150 times 1.055 to the x. All right. 5 and 6, I want you guys to try them. Go ahead and push pause on the video until you've done 5 and 6, and then push play when you're ready to see the answers, okay? Push pause now. And here are your answers. Now notice, both of these, is a decline here and a decline here, so that's a decay. So I started out with my decay. They both had an initial value that was given. That's our A. They both had a rate as a percent, change them to decimal, so that's 0.15, this is 0.025. And then simplify if you can, and notice both of these B values is less than 1 because it's a decay. I'm going to stop the video here. We're going to continue on the next video.